I'm Daniel Kępski. I work in Institute of Geophysics, Polish Academy of Sciences. And today I will tell you about the snow, and especially snow in the Arctic and in the Arctic ecosystem. So maybe I should start from the beginning. So to have a snow cover, we need first snowfalls. And to have snowfalls, you have to there are three necessary conditions to have snowfalls. So we need to reach the dew point temperature. We need a presence of a condensation nuclei, and I know that it can sound a little bit strange and complicated, but I will explain everything in a minute. And the third necessary condition is the air temperature below 0 degrees of Celsius. Yes, so obviously, if we want snowfalls, we have to have negative temperatures. So what's going on with this dew point temperature and the condensation nuclei? So everywhere around us there is some water vapor. Yes, so this water vapor comes from evaporation of water from lakes, rivers, seas, plants. Even if I talk to you, I produce some water vapor in my breath. So water vapor is always around us, and to have clouds and to have then precipitation from these clouds, we need to condensate this water vapor have to be condensate on something. So there is always some water vapor around us, and the air can store certain amount of this water vapor. This amount is strictly connected to the air temperature. So in warmer temperatures, there can be more water vapor in the air, and in the colder temperatures there is smaller amount of water vapor that can be stored in the air. And we know that usually in the mountains it's much colder than at the sea level. So if the air is traveling up with this water vapor, it cools down, and if it cools down, it reaches this temperature where it starts to condensate. Yes, so this is the dew point temperature. And to have a condensation or sublimation, so to transform the gas into the liquid or to the solid form, we need also the condensation nuclei. So we have something that is floating in the air, and on these particles the water vapor can condensate or sublimate. So this is the condensation nuclei, and condensation nuclei can be anything. It can be a pollen from a plant, it can be a soot from a chimney, it can be a small particles of dust, and many other things. Everything that is liquid or solid and if it's floating on the air can be a condensation nuclei for water vapor. And obviously we need the air temperature below 0 degrees of Celsius if we want to have snowfalls. In reality, the things are a little bit more complicated, because in the clouds, when we have negative temperatures, there is always a mixture of the supercooled liquid droplets and the snow crystals. So solid and liquid form is mixed together. And there is something that is called Bergeron process, and I don't want to get too much into the details, but it's maybe worth to know. And in the brief, this Bergeron process means that sharp edges of snow crystals attract water molecules more than spherical shape of liquid droplets. So this is why the snow crystals are growing in the clouds and these liquid droplets are shrinking. And if these snow crystals grow, if this process continues, the snow crystals can be a bit big enough and heavy enough to fall down from the cloud in form of snowfall. And here it's worth to emphasize that practically all precipitation that are occurring in our planet starts as a snowfalls. So even the tropics, when we have temperatures like 30 degrees of Celsius, the precipitations are forming high above us, where it's much colder, and precipitation start as a snowfall. And as this precipitation, as these snowfalls go through the warmer layers of air, they melt and they reach the ground in form of rainfall instead of snowfall. But usually all precipitation starts as a snowfall. Okay, and let's go more into the details. You probably know, observe, or heard that there is millions of snowflakes, snowflake shapes, and usually you don't that every snowflake is unique, and that's true, or it's close to the reality. Right now we know that identical snowflake shapes can be spotted in the nature, but the number of combinations is so large that it's very unlikely to have two identical snowflakes, but it's possible. And the latest classification from year 2013 says that there is 121 types of snowflakes. And but obviously this is a generalization, and this means that there is 121 types. So these types are here we have some examples. We have plates, we have dendrites, we have stellars, and so on and so on. But obviously there are millions of combinations or billions of combinations of dendrites, plates, stellars, and so on. So this is only a generalization. And this chart here is a Nakaya diagram, and it's this shows which types of snowflakes we can expect in which conditions. So we have the temperature here and supersaturation here, and supersaturation may be a complicated term, but so let's simplify this and say that this is the air humidity. Yeah? So this can be air humidity here. And here from this diagram we can see that the biggest and also the most beautiful snowflakes are created in conditions like in very high air humidity and in the temperatures like in the range of -10 to -22 degrees of Celsius. And but you have to remember that this diagram shows the conditions that are in which these snowflakes are forming. So we can have a situation when we have 0 degrees of Celsius and we see such large, nice stellar forms of snowfalls. So this means that high above us in the clouds we have probably temperatures from this range. Okay, going further. Right now we will be mostly interested in the snow cover, not the snowfalls. But obviously, to have snow cover, we need first snowfalls. And so generally, snow on the ground is a snow cover, but there are some definitions. Yeah, so it's good to know that in meteorology, day with snow cover is counted only when the thickness of snow on the ground exceeds half of centimeter and covers at least half of the terrain. So on the picture on the left, we are sure that we have snow cover here. But on the right, there is we had some snowfalls, but as you can see, this snow doesn't cover the whole ground and is also very thin, so it not exceed half of centimeter. So we have snow on the ground, but it's not a proper snow cover. Okay, so let's go further. Let's talk about snow metamorphism. So from this lesson there will be it's good to remember at least one thing. So I want you to remember that snow cover change all the time. So this is the most important message here. And many things shapes our snow cover. So here we have a graph that is showing what influences the snow cover, and as we can see here, there is a solar radiation, long wave radiation from the reflected from the clouds. We have wind activity that creates snow drifts. We have some exchange of the heat from between the ground and the snow cover. We have the exchange of the heat between snow cover and the air. So we have a lot of processes here, and it's really complicated. So practically everything matters have an influence on the snow cover properties. But the most important factor here is temperature again. But here maybe not air temperature, but rather the temperature inside the snow cover, so the gradient of the temperature in the snow cover. And depending on this gradient, we can have different types of snow metamorphism. We can have isothermal snow metamorphism, temperature gradient metamorphism, and melting is also a form of metamorphism. Yeah? And so right now, let's imagine the situation that we have 1 meter deep snow cover, and if we measure the temperature inside this snow cover, we have -1 degrees at the top of the snow cover, and we also have at the bottom of the snow cover temperature close to -1 degrees of Celsius. Let's say it's -1 degrees of Celsius. So in this situation, we don't have any gradient in the snowpack, and we have isothermal conditions. And in such conditions, our snowflakes are behaving like this. So it's good to know that if we have these snowfalls are metamorphosed during the winter. So if we see the snow crystals after a month of the last snowfall, you won't see any nice stellar forms, but rather something like here. Yeah, so rather rounded grains. So this when we don't have any gradient inside snow cover, our snowflakes behave like this. So they are transformed into rounded forms. So here we have days. So after 54 days, we should have a perfect spherical shape. Obviously, this chart presents the situation in laboratory, in the perfect conditions, and in the nature, we don't have isothermal conditions all the time. So there is some temperature fluctuations and so on. So in reality, it looks rather like here. So we don't have perfect spherical shape, but rather our snow crystals are transformed into something like here, if you see my mouse. And let's imagine right now that we have the same snow cover, but right now the temperature gradient is high. So if we have strong colds, and let's say the air temperature is like minus 40 degrees of Celsius, we will have a situation when at our top of the snowpack we will have the temperatures similar to the air temperature, so like let's say minus 40 degrees. But at the bottom of the snowpack we will have temperature close to the 0 degrees. So because snow cover is a perfect insulator, so it means that deeply below the snow cover, the temperatures are higher than at the top. So if we have such high temperature gradient, in such situation, our grains will be transformed in different way, and they start to be spherical and faceted. Not spherical, faceted. So they start to have cubic and pyramidal shape, and this is very important because such pyramidal shape is very unstable, and in the mountains presence of such crystals is a serious risk of avalanches. Yeah, so these crystals are very unstable, and the avalanche risk is much higher if we have such crystals inside our snow cover. And I said that there is a lot of factors that influences our snow cover. So you can guess that in different climatic conditions we will have different snow cover properties, and that's true. And probably you think that in the high Arctic you have a lot of snow, and obviously that's true. We have a lot of snow in the high Arctic, but in fact in tundra, so in the tundra is the biome that dominates the high Arctic. The snow cover depth is not very impressive, and usually we have snow thickness here like 50 centimeters, so it's not so much. And the reason is why is that? Because we have in cold temperatures there is not so very not intense. We don't have many intense snowfalls. Because in low temperatures there is less water vapor and so on. That's one reason. And the second reason is that we have open spaces without trees, and the wind activity is really high in such conditions. And this wind activity can compress our snow cover, so it can pack this snow cover in very dense layers. Different situation is in taiga. So let's say low Arctic, when we still have trees. These trees block the wind activity, and inside the forests we don't have much of wind activity. So this snow cover is much looser. Yeah, so it's really hard to stand on snow surface in such conditions. If you have loose snow, you need skis to travel on snow surface. Usually in the tundra, the snow is very compressed, and it's really easy to walk on the snow surface. It's really hard snow cover, and generally it's really easy to move on such surface. And as you can see on this chart, the highest snow cover depths are found in alpine and maritime conditions. So maritime conditions means, let's say, let's say Japan is the perfect example of maritime conditions. So we still have winters and negative temperatures during the winters, but we have a lot of sea influence. Yeah, so there is a lot of water vapor coming from the sea, and this snowfalls can be very intense there. And in high mountains we also have a lot of snowfalls, so the snow cover can be very high there in such conditions in the high mountains, and we have a lot of layers in such conditions. And obviously, some snow crystals can be formed only in specific climatic conditions. So it means that, for example, depth holes layers, these very unstable layers that have pyramidal shape, can be found only in the Arctic or high mountains when we have proper colds. Yeah, so very strong negative temperatures. In maritime conditions, rather we found these rounded grades, melted forms, and so on. And so I'm talking a lot about these snow cover properties, and you may ask why it's important, why scientists should study snow cover. So there's a plenty of reasons. So in our climatic conditions, let's say the most important thing is the avalanche risk. Yes, so if we know the structure of the snow cover, we may predict the avalanche risk and save the people's lives. Yeah? To warn the people to not go to the mountains and so on. Another very important thing is the hydrology reasons. So if we know how much water is stored in the snow cover, we may predict the floods or droughts events. So it's very important for the agriculture and also for the safety of the people. In the Arctic, probably the most important is impact on the climate. So you probably know that if you have a warm and sunny day, if you wear white t-shirt, this white t-shirt reflects a lot of sunlight, so it helps us to cool down in very sunny conditions. Yeah. And the same is with the Earth's surface. If we have Earth's surface covered by the snow, it reflects a lot of sunlight. And if the Earth's surface is without snow cover, the albedo, so this reflection is there is way more solar radiation is absorbed by the Earth's surface, so the Earth's surface is going warmer and warmer. So this is another thing that fasten our climate warming. Another thing is the influence of vegetation. So you probably may think that snow cover is a bad thing for vegetation, and yeah, sometimes it's a bad thing. For example, if you have a really intense snowfalls, these snowfalls can damage our trees. Yeah, so this is negative influence. But in the Arctic, especially in the Arctic, but not only in the Arctic, we also see positive influence of vegetation. And there are many studies that shows that under the deep snow cover, the plants are healthier and grow bigger because of this insulating effect of snow cover. So if we have temperatures like 0 degrees deep beneath the snow cover, it's much better for plants than, let's say, -40 when we have strong colds and there is no snow cover. So these plants are well, don't have any insulating cover that helps stay warm beneath the snow. And there are also other reasons. So studying snow cover is important in snow. It's important tourism. It's also has a meaning in architecture. So the snow cover can be a threat to buildings. We have some famous catastrophes that were problematic. So there is a lot of things that matters. And you may ask what we can measure in snow cover. So probably the easiest thing to measure is the snow cover thickness, and this is very simple to measure. So you need only a ruler to measure the snow cover. If snow cover depth, if the snow cover is very deep, you need some longer ruler. So for example, avalanche probe. So it's very easy to measure the snow cover high. And obviously in 21st century, we have some automatical instruments. For example, we have acoustic devices that measure the snow cover thickness in such way that this sensor here sounds acoustic wave, and this acoustic wave reflects from the ground or the snow surface and it returns to the sensor. And on the base of the time of this return, you can say how much snow cover is on the ground. Yeah. So obviously this sensor takes into account also the air temperature, because the sound speed of sound propagation in the air is strictly dependent on the air conditions, air temperature especially. And other thing that you can easily measure is the density. So to measure density, you only need to have something that you know the volume. And if you know the volume, you may weigh the snow on some scale, and you then have the density. And if you have density, it's really and you have density and snow depth, it's very easy to measure the snow water equivalent. so how much water is stored inside snow cover. But if you want to measure more, if you want to have snow layering, you need to dig something that is called snow pit. So snow pit is just a hole inside our snow cover. And in such snow pits, you can easily see that snow is heterogeneous and built from many layers. And this is another very important message. Yes. So always, if you have snow cover and it persists on the ground for, let's say, more than 2 days or something like that, this snow cover will have many layers. And in snow pit, you can easily see that. So, for example, you can have perform this such experiment if you have some snow cover around you. Probably it's this winter in Europe is not the best, but if you will be in somewhere in the mountain, you may dig such small snow pit and pour something that colors that is colored into the snow pit wall, and you will see that this water will travel through the snowpack differently. So there are layers, so the water will stop on some levels and so on. You may use, for example, here is rhodamine, it's pink dye, but you can use the cold coffee. So coffee is also good for such experiment. And in snow pits you can measure very a lot of things. I don't have time to explain everything, but maybe here this is quite important, temperature. So you can, for example, use the thermal camera, and on such thermal camera you can easily see how temperatures looks inside the snow cover. So if we have cold day, at the top of the snow cover we will have temperatures like here, for example, minus 14 degrees. And at the bottom of the snow cover, it's not very deep, it's like 50-60 centimeters if I remember well. At the bottom of the snow cover you have temperatures like minus 3, so it's much warmer at the bottom of the snowpack. What we can measure in snow pits, let's say one example will be snow crystals. So if you dig such snow cover, and scientists that performs these measurements classify the snow crystal grains in each layer of snow, and we have a classification, and the latest classification distinguishes nine main types of grain shapes. And so you can spot inside the snow cover different snow crystals. Freshly fallen snow crystals looks like that, but they are very fragile, and they last, let's say, after the snowfall, they can persist for several hours. After several hours, wind activity often breaks these crystals, and they start to looks like here, so they are broken. And when the time passes, we have metamorphism processes, and these crystals start to looks like here or here. So if we have isothermal gradient, the crystals will be rounded. If we have higher temperature gradient, we will have faceted crystals like here, or the depth hoar crystals like here. So this pyramidal shape that are very dangerous in the mountains. But on the other hand, these crystals are very good for animals that live inside the snow cover. So there are many rodents that dig tunnels in snow cover, and such crystals are pretty loose. So if we have such crystals, these animals can dig tunnels easily. But if we have different conditions, and we have, for example, thaws, and the rainfalls are present in the winter, these rainfalls can create ice layers inside snow cover. So these layers are very hard, and they are quite problematic for the animals. For example, reindeers can have a problem to access to the food. Yeah, so they dig the shrubs from the snow cover, and if we have thick ice layer, they have a big problem to get access to the food. So everything matters here. And obviously there are many things to measure in snow cover, and sometimes you don't need to have to dig a snow pit. For example, you can also measure the albedo of the snow cover, so how much solar radiation is reflected from the snow cover. So usually freshly fallen snow have really high albedo, but if we have a lot of pollutants, let's say a lot of black carbon inside snow cover, this albedo is much lower, and this is a bad thing for the climate because such snow cover will melt faster. So there are some specific devices to measure the albedo above the snow cover. Some analyses can be performed only in chemical laboratories, so you cannot measure everything on the site. Sometimes you need to collect the samples and send them to the laboratory and have chemical analysis what's inside of the snow cover. Yeah, so you may not see on your own eye the black carbon inside snow cover, but it's usually there. So this influences the albedo. Okay, so the results of field observations, results of snow pits are most often presented in this way, like here on these charts. It's maybe it's worth to emphasize that snow cover examination snow pit may take several hours. So my personal record was 12 hours inside the snow pit. Inside the snow pit, it was 3 meters deep. But I know from my colleagues from Polish Polar Station Horsund in the Spitsbergen that such snow pits may take even longer. It may take even 3 days. Yeah, that was the record. If I remember well. So my colleagues have a snow pit that has 7 meters deep, and that was 7 meters deep. And with the digging and with the examination of the snow layers inside the snow pit, it takes 3 days. And on the end, you have something like this. So this is a snow pit chart. This is the most classical way of presenting the data. So we have here everything that we measure. So the hardness, density, and the snow crystal forms, the grain size of these crystals, and you can put even more things in this chart. It depends which analysis you perform it in the snow pit. And as I said before, we have right now 21st century, so we have a lot of automatic devices, and we have satellites. So satellites allows tracking changes in snow cover extent, and microwave sensors on this satellite or on other satellites give information about snow water extent stored in snowpack for almost every place on Earth. So our Earth surface is constantly monitored by the satellites, and we have a lot of information from these satellite sensors. So they are really easily accessible, and you can have a data practically constantly to see how it's going on with the snow cover in Europe or anywhere in the world. But you have to remember that even now satellites have pretty low resolution, and if you want to measure exact snow water equivalent on some small catchment, it will be hard to use the satellite data. So this is why we need also these snow pits and this data that are collected in the field. So if you have some global studies, satellites are very helpful. And if you want to measure, let's say, snow water equivalent in some complicated terrain in some small mountains, then you need to have, then you need to dig snow pits. So right now we know which processes are shaping our snow cover. but let's say a little bit more about ecology of the snow cover. So snow is a living environment, and we have a lot of animals and plants that lives inside the snow cover in snow cover condition in snow conditions. So starting from the microlife, we have a lot of algae. So in high concentrations, these algae can make our snow cover colorful. So here we have a picture of the watermelon snow. It's called like that because of this red color and also the smell that is similar to watermelon. So we had a lot of algae that can live in snow cover, and they can, in high concentrations, then can make our snow red, orange, pink, or green. There is no algae that make snow yellow, so be aware of yellow snow. And we also have spiders, springtails, so some kind of snow fleas that lives in snow cover. Even we have some wasps that can survive the winter inside snow cover. So there is a lot of life, micro life there. And obviously, under the snow cover, we have plants. And for example, in the high Arctic, in Spitsbergen, we can find this plant here. It's Saxifraga. Oppositefolia. Its adaptation for living in such harsh climate is the ability to bloom just after the melt of the snow. So these flowers need very small amount of sunlight to bloom, and they can bloom even under the snow cover. So when the snow is thin and it melts, these flowers may bloom even with the snow cover above. And we have a lot of microlife inside snow cover, and we also have some rodents, some mice, voles, or lemmings that dig tunnels inside snow cover, and we have also bigger animals that hunt them. So here we have weasel, here we have fox that have some specific hunting technique. They dig inside snow cover to when they hear some sound produced by mice. And we have also birds that can survive the winter. So for example, in Svalbard, we have rock ptarmigans that stays for the whole year in the Svalbard archipelago. And they have this winter camouflage and a lot of abilities that help them survive in such harsh conditions. So here are some examples of this snow camouflage. Rock ptarmigans during the winter, they are perfectly white, and during the summer they change the feathers and looks like here. So looks completely differently, and it's obviously everything is to avoid the predators. Yeah, so if they are white on the snow, it's really hard to see them. And similarly here, they are in similar colors like the tundra. And obviously the predators also have such adaptations. They didn't want to be seen by the prey. So in the winter, the Arctic foxes are white, and during the summer they are rather black. And there is also this transition period in the spring when they don't look like really pretty because they change the fur from this white to black, and they look like here. And when we try to draw a food chain in such Arctic or snow environment, it might be quite complex. So it's not so different from the other food chains in different climatic zones. We have a lot of connections. We have a lot of a lot of animals that lives in such snow environment, and organisms that live in the snow may be divided into subnival, intranival, and supranival ones. So subnival are these animals that lives under the snow cover. Intranival, these animals that lives inside the snow cover, so mostly the micro invertebrates or spiders or something like that, but also these rodents that dig tunnels in snow cover. And we have also bigger animals, supranival animals, like for example Arctic foxes that live above snow surface, but they often eat other animals that lives inside snow cover. And maybe on the end, it's also worth to mention the lot of problems that have snow environment with the climate warming. So there is a lot of problems. For example, there is something that is called browning of tundra, and it may be weird, to have global warming and browning of tundra. So usually you can rather expect that the tundra will be more green, but in fact there are some processes that damage the plants within this when we don't have a lot of snow cover. So when we have thinner snow cover, the plants are more easily damaged by the frosts that can still happen. Yes, so we have warmer climate, but still severe frosts can occur, and if we have thin snow cover, the plants will be more damaged than in places where we have deep snow cover. And it's also good to remember that the snow cover is the main freshwater source for Arctic plants, and these plants are adapted to get water from the melting of snow cover, and it's usually a long process. If we in the warmer climate, we will have less snow cover and more rainfalls, and rainfalls can be very intense, but in short periods. So the Arctic plants are not adapted for such conditions. They prefer the slow melting of snow cover and getting water from this source. So with climate warming, we have more frequent rain on snow events during winter, that leads to formation of ice layers. And I said something about that before. So ice layers can be very thick, and these ice layers are problematic for example, reindeers. They cannot get access to the food, and they can die from starvation in such conditions. And going further, the climate warming may go faster due to increased absorption of solar radiation when the snow is absent. The organisms are not adapted to live without snow, so the animals have to change the life strategies to adapt to the new climatic conditions, which can be difficult for them. And there is a lot of more problems. So the stabilization of permafrost may release potentially dangerous microbes from the distant past, and it's not a science fiction. It happens right now. So there are studies that shows that some reindeers were found dead, and they were killed by the microbes that was released from the permafrost thawing. So there is a lot of problems with climate warming in snow ecosystem, and so it's good to emphasize that we have such problems right now. And okay, thank you very much for your attention. I think that was a lot of knowledge for today. But if you want even more knowledge, you can find the educational toolkit that was created on this topic. So on this website, you can find the educational toolkits, and there is a toolkit that is called like today's presentation. So snow in the Arctic ecosystem, and there is even more knowledge about snow ecosystems on our planet. So I really encourage you to check this educational toolkit. And for now, I think it's enough. Thank you very much for your attention. And if you have any questions, you may ask right now. Thank you.